Hello. Today we are going to work these review problems that we have. Number 1, automotive airbags inflate when sodium azide decomposes explosively to its constituent elements according to the equation. 2 sodium azides give you 2 sodiums and 3 nitrogen gases. How many moles? So we're solving for moles of nitrogen are produced by the decomposition of 2.88 moles of sodium azide. So now we know what our known is and what our unknown is. All right, we'll start with our known, 2.88 moles of sodium azide. The ratio of sodium azide to nitrogen, 2 moles of sodium azide to 3 moles of nitrogen. All right, that is how you get the first one set up. Number 2, magnesium burns in air with a dazzling brilliance to produce magnesium oxide. According to the equation, 2 magnesiums plus oxygen gas gives you 2 magnesium oxide. How many moles of oxygen are consumed? So that is what we're solving for. When 0.770 moles of magnesium burn. So we start with our known amount. Now, the ratio of magnesium to oxygen is 1 mole of oxygen will react with every 2 moles of magnesium. And that's how you set up the second one. The third one, we know that we have 2.5 grams of aluminum. We also knew we have 2.5 grams of oxygen. So this is a limiting reactant. We are making aluminum oxide. We need to write out a chemical reaction. So we start with what we're given. We know we have aluminum. We know it's going to react with oxygen gas, and it's going to produce aluminum oxide. The next thing you have to do is balance this. We have 2 oxygens here, 3 oxygens there, so we're going to double that guy and triple that guy. That made 4 aluminums. So we have 4 aluminums plus 3 oxygens gives us 2 aluminum oxides. All right. Limiting reactant means we're going to solve for both of these reactants, and then we're going to figure out which one made less, and that will be the limiting reactant. And the limiting reactant will make less of what we're solving for. Our unknown is aluminum oxide, so the smaller amount. So we start with 2.5 grams of aluminum. Now we come to a conundrum because we do not have moles. We are starting with grams of aluminum. So looking at the mole map, you change grams to moles by dividing 2.5 grams by 26.98 grams in 1 mole. All right, that changes us 2 moles of aluminum. Now we can do our mole ratio. We're solving for aluminum oxide, so our ratio will be 2 moles of aluminum oxide for every 4 moles of aluminum. Okay, we want the maximum amount, so we're going to solve in grams. So how do we change back to grams of aluminum oxide? And what is the molar mass of aluminum oxide? Well, 2 aluminums would be let's just do it this way. Al2O3 101.96. 101.96. The next one we're going to do, we're going to solve for aluminum oxide again, but this time we're going to start with 2.5 grams of oxygen. I'm going to make this a little smaller. I've got 2.5 grams of oxygen, and I want to solve for aluminum oxide once again. Molar mass of oxygen is 16, but don't forget we have 2 oxygens here. So the molar mass of oxygen, the molecule, is 32 grams in 1 mole. That changes us to moles. Now we look at our ratio. This time we're going from, we've got 3 oxygens that react with 2 aluminum oxides. No. Two moles of aluminum oxide. And then our molar mass is still 101.96 grams in 1 mole. And the one that makes less, even though this says maximum amount, it's like the question of s'mores. If you have 6 graham crackers, you can make 3 s'mores. If you only have 2 marshmallows, you can only make 2 s'mores. So the maximum number of s'mores you can make is 2. Even though the graham crackers would make 3, there's no more marshmallows.